In this problem, we are going to talk about solving a problem using derivatives. We are given a revenue and a cost function. We're asked to find marginal revenue and a profit function, as well as marginal profit at a certain value. So let's read the problem. If the total revenue received from the sale of X items, so X represents items, is given by R of X, my revenue function equals 30 times the natural log of the quantity 2X plus 1, while we know the total cost to produce X items is C of X equals X divided by 2, or 1/2 X. Let's find the following. So for the first part, we want to find the marginal revenue. When we see that word marginal, that means we're going to differentiate. In this case, we're going to differentiate with respect to X, our independent variable. Now, we're going to be taking the derivative of a natural log, and what we know is that the derivative with respect to X of ln X is going to be 1 over that argument X. Now, in this situation, the derivative of this natural log, it's not just an X value. We have a composition here. So the derivative of a composition natural log, so d dx of the natural log of, say, some function g of x, well, it's still going to be 1 over that argument. So g of x goes into the denominator. There's a little invisible 1 in the top. And then over here, we would multiply by the derivative of the inside. And really an easier way to write that, we can just slide that g prime of x into the numerator. So it's the derivative of the argument, 2x plus 1, over the argument. So I'm going to take my r of x formula and say that r equals 30 times the natural log of 2x plus 1. And if I differentiate with respect to my independent variable x, I now have that the derivative of r with respect to x, the 30 is a coefficient, so that remains. And it's going to be, the argument goes into the denominator, 2x plus 1. In the numerator, we have the derivative with respect to x of 2x plus 1. Of course, we see that that derivative is just 2. So we end up with 2 times 30 gives me 60 over 2x plus 1. This is r prime of x, or my marginal revenue function, 60 over the quantity 2x plus 1. So again, when we see that word marginal, that means we're going to take the derivative of the revenue. This is marginal revenue, so the derivative of the revenue. Part B asks us to find the profit function. For profit, we need to know that profit is the difference of all the revenue, all the money you take in, minus the cost. So in this situation, part B, my profit function, P of X, equals revenue, which is given, 30 natural log of 2x plus 1, minus all of my cost function. In this case, my cost function is only one term, but do notice I drew a parenthesis here so that if it was multiple terms, I would need to remember to distribute that minus. In this case, we're just going to have x over 2, and remember, x over 2, that's the same as writing 1/2 x. So this function here, this represents my profit function. This would be the answer for part B. So when we look at part C and we see that it asks us to find marginal profit is going to be the derivative of profit. So P prime of X equals, we just found the derivative of this first term. It is that marginal revenue function. So it's 60 over 2x plus 1. And then we would have minus the derivative of this term, and the derivative of that is 1/2. So the marginal profit, when you let your X value, X being items, when X is 60 items are sold, P prime of 60 equals 60 over 2 times 60 plus 1 minus 1/2, or rather 60 over 121 minus 1/2, which is essentially 0. So what does this mean? The marginal profit, the additional profit from selling one extra unit when we have 60 items manufactured, that additional profit is essentially 0, or there is no profit from selling those additional items. All right, so that's it for this example. The main thing you want to remember with these word problems is when you see those words marginal and you're dealing with profit, revenue, and cost, that means we're going to be finding the derivative because that's the rate at which the profit is changing.